So the lesson in College Algebra 2.3 is all about completing the square. Now this is a technique that last year in Algebra 2 we used to mostly solve quadratics, but this technique comes in handy for rewriting certain equations into other forms. So f of x equals ax squared plus bx plus c is a general quadratic function. The graph is called a parabola, remember from Algebra 2, parabola. And the domain is negative infinity to infinity. This is another form of that quadratic function. It is called vertex form. The reason we call it vertex form is because we could easily identify the vertex when it's written in that form. So, this particular case, these three problems are all written in vertex form. If I go back to the last slide, you would have saw, oops, excuse me, x minus h. Too close to the top of the paper, sorry. The vertex is at the point h comma k, so it has to do with how far the parabola was shifted right or left or up or down. So for here, the vertex is located at -2, +1, because remember in the formula it's x minus h, so when it says x plus 2, that's really x minus a -2. And then, does it open up or down? That has to do with the value of a. If a is a positive, it opens up, so in this case we have an up opening parabola, and if it's negative it opens down, and then the axis of symmetry is the line that would cut this parabola in half. So a vertical line of x equals, and then the x value of the vertex is where it is cut in half. So this next function, the vertex is at +5, -8. I notice the a value is positive, so it opens up. And your axis of symmetry is at the line x equals 5. And then our last example, the vertex is at opposite of this, so -3, -4, -3, -4. And it's this time going to open down since our a value is a negative. And the axis of symmetry is at x equals -3. It's important for the axis of symmetry that you give me the entire equation for the axis of symmetry. Okay, now we're going to relearn how to complete the square. This is something you did in Algebra 2 quite a bit. So what I want to do is create this trinomial to be a perfectly square trinomial, meaning it factors into a binomial times itself again, so a binomial squared. And the way we do that is we take half of our b term, and then whatever that number is, we're going to square it, and that's what goes in place of this blank right here. So half of our b term would be a 3, and then 3 squared gives us 9. Then because this is now a perfect trinomial, I could easily factor it into x plus 3 times another x plus 3, or x plus 3 quantity squared. This example, half of your b term is a -4, but when I square a -4, I always get a positive value, in this case a +16. So when I go to factor this perfect trinomial, he's going to factor into x minus 4 times another x minus 4, or x minus 4 quantity squared. They're always going to factor beautifully like that, because that was the whole reason I picked b over 2 squared, so it would come out to a perfect square trinomial. This next example is a little funky. If I take the b value and cut it in half, and then I square it, I don't want to bother with decimals here, especially in College Algebra, because decimals are going to be terrible for us later on. So squaring 11 halves, I get 121 over 4, and that's what I put inside of this blank. Now, I hope you've noticed that the thing that goes in this next blank is just half of my b term, because I'm going to square it, and that's how I'm going to end up the third term. So half of my b term, the thing I had before I squared it, was just the 11, whoops, it says 11 over 2. And then this example, half of my b term would be -9 over 2, but then I'm going to square that to figure out what goes in this blank. So that would be a +81 over 4. And then to factor it, I know it's just going to be x and then half of your b term, so -9 halves. So if you know the pattern and you know how to come up with the numbers, it doesn't have you do a whole lot of thinking, but it does sure help if you know why the pattern works. So now we're going to solve by completing the square. When you solve a quadratic by completing the square, you want it in the form x squared plus bx, and I'm going to say plus blank, equals the constant plus blank. So you'll notice here they've already moved the constant to the right side. That's good. I'm just going to rearrange it a little bit. I'm going to leave a blank for when I complete the square, And then to keep things balanced, whatever you do to the left side of the equation, you also need to do to the right. So the thing that goes in the blank is half of our b term and then squared. So half of negative 4 is negative 2. Negative 2 squared is a 4. I got to add it to both sides of the equation. Now the whole reason of us writing it like that is so now we can factor it into a perfect binomial that's being squared. So it's going to be x, and then half of your b term was a minus 2. Quantity squared equals 12. This is still a quadratic equivalent to the original problem, except now I can solve this quadratic through square rooting. So when I square root both sides, I get x minus 2 because the square root and the square cancel each other out. And then breaking down the square root of 12, I need to rationalize it and keep it pretty, and I also need to remember that since I'm solving, it's positive and negative. So square root of 12 breaks into 4 and 3. So my final answers, I should say, for this question, I'm going to add 2 over, I'm going to get 2 plus and minus 2 square roots of 3. And those are the two answers. Those also happen to be the two answers you would get had you chosen to solve that quadratic through quadratic formula. But no one likes quadratic formula, so I like completing the square. Now the catch with completing the square is it's not always a great idea. For instance, here, you can only complete the square in a quadratic if this first term is a 1 coefficient. Since he's not a 1, if you choose to complete the square, you're going to have to make him a 1, so we're going to have to divide everybody by a 2. So my new problem, my new quadratic, is p squared plus p, this is going to be ugly, plus 1/2 equals 0. Now to complete the square, I'm going to rewrite it, and I'm going to leave a blank. And I don't know if you noticed already why it's going to be ugly, but it is. Okay, half of the b term is a 1/2, and then when I square a 1/2, I get a 1/4, and I'm going to add it to both sides. Now, when I take this quadratic, and now I factor it into his binomial squared, it's p, and then half of the b term would be a plus 1/2, quantity squared, negative 1/2 plus positive 1/4 is a, let's see, negative 1/4. And now I need to think about some things back from Algebra 2. When I square root a negative 1/4, it's still plus and minus because it's still an equation. I'm going to square root the numerator and denominator separately. The square root of a negative 1 is an I, and the square root of 4 is a 2. They didn't tell me to only come up with real answers, so in this case I am going to want to get real and also imaginary answers. And then your last step, you would subtract the 1/2 over. Now, you will notice that we have common denominators here. It wouldn't be wrong if you decided to write your answer as negative 1 plus or minus I all over 2. That would be a great answer as well. Okay, 10 is going to be gross. The first coefficient is not 1, so I got to make it a 1. Yuck. I don't know who wrote this question. It wasn't me, but well, maybe it was me. Either way, we're mean people. Sorry. Z squared minus, now 12 over 9 does reduce to, let's see, 4/3. So we got 4/3 Z. I'm going to go ahead and leave a blank here. I'm going to add the 1/9 over just to save some space. And then remember, we got to add it to both sides of the equation. Okay. Negative 4/3 cut in half would be multiplying the denominator by an extra 2. So that would be like negative 4 over 6. But we know that reduces to a negative 2/3. And then when I square that, I get positive 4 over 9. Now, it's not horrible if you decide you want to do that work in your calculator, but you are college algebra, so I want you to try to do a little bit in your head. If it's a test, though, make sure you get it right. I don't care how you get it right. I'm going to factor this new quadratic, z, and then half of our b term we decided was a negative 2/3. So I'm going to write it like this, squared, equals 1/9 plus 4/9 is 5/9. Okay, almost done. We're going to square root both sides. And we get z minus 2/3 equals positive and negative. Now I square root fractions, numerators and the denominators separately. The square root of 5 is square root of 5, nothing else. Square root of 9 is something pretty, it's a 3. So I'm going to write this as the square root of 5 over the whole number 3, and then my final answer, when I want to add the 2/3 to the other side, plus and 2/3 plus and minus square root of 5 all over 3. Now again, you have common denominators, so it wouldn't be inappropriate if you wanted to smush these together into one fraction, although you still clearly see the two answers. And if your buddy next to you did this problem through quadratic formula, he would end up with the same exact answer that you did. So either one of these versions is perfectly fine. Now we're going to use a similar technique of completing a square, but we're going to take a standard form parabola and rewrite it into vertex form. It's a little different. What we're going to do is we're going to only work on the right-hand side. So first coefficient has to be a 1, check. Then I'm going to write x squared minus 2x, and then I'm still going to leave a blank. This negative 4 is going to stay where he's at, but to keep things balanced, whatever goes in this blank, since I'm still on the same side, I'm going to have to subtract him off to make sure things are balanced. So half of negative 2 is negative 1, negative 1 squared is 1. I'm going to add 1 and also subtract 1. Now, some kids go, why did you do that? They just cancel each other out. Au contraire, because we are going to selectively group. This quadratic we are going to be able to rewrite as the quantity x minus 1 squared, because we just completed his square, and then negative 4 minus 1 is better known as a minus 5, and look what you got. You have a function in vertex form. If I asked you to identify the vertex, you could do it very quickly. It's positive 1, negative 5. Done and done. The next example, a little more complicated because this coefficient has to be a 1. Ooh, this one's going to be fun. We're not going to divide by 2 because if I divided by 2 on the right-hand side, I'd also have to do it on the left-hand side, and I don't want to do that right now. So instead of dividing by it, I'm just going to temporarily factor him out and remove it from just the first two terms. So I'm going to take a 2 out, and then I'm left with, oh, that's funny, they used f of x, but they meant q. Sorry. 2, and then q squared minus, now this is where it gets weird, I factored a 2 out of an 11, that's like dividing. So I have 11 over 2q, and then we're going to have a blank here. I still have a minus 21, and then whatever I end up adding here, I'm going to have to remember to remove it off to the side because that way things will stay balanced. So, gotta think a little bit. 11 halves, cutting another half would be adding or multiplying another 2 into the denominator. So that'd be like negative 11 over 4, and then when I square that number, I get 121 over 16. Now, here's the catch. 121 over 16 is really being multiplied by 2. So I need to figure out what that number is, and that's what I have to subtract over here. So let's see, 121 over 16 would be 121 over 8 when I multiply it by 2. Boy, ugly. Use your calculator. So we're almost done. 2, and then q. Remember, half of the b term goes next, so minus 11 over 4, quantity squared. And then, oh goodness, I don't know how to do that in my head right now. Negative 21 minus 121 over 8. Back to a fraction. Ooh, yuck. Negative 289 over 8. I won't promise that I didn't mess up on that question, so apologies if this was not correct. But that's what I got. So my function, using q as its variable, gives me that. Yuck, yuck, yuck. Okay, 13's not looking much better, guys. We're going to have to be very strategic and factor out the 9 from the first two terms. And again, someone went nuts. They forgot to use the variable z here. So anyways, factor a 9 out. That leaves us with z squared minus. Now 12 divided by 9 is, I should be able to do this, 4/3 z. We're going to add something to make it perfect. And then we still have the plus 8 off to the side, and then we're going to have to subtract something to keep it balanced. So, negative 4/3 cut in half would be negative 4/6, which is negative 2/3. And then I'm going to square it. So that would be 4/9. Oh, I almost wrote 4/9 again. Remember, this is 9 times 4/9. 9 times 4/9 is a 4. So instead of just subtracting 4/9, I'm going to have to subtract a 4 because of that first 9 coefficient. Believe it or not, you're almost done. So the function of z is 9, and then z minus 2/3, half of this guy, squared. And then 8 minus 4, I can do that. That's a plus 4. So the vertex of this particular parabola is 2/3, 4. Good to know. These next problems are interesting. They give us looks like a picture off of a calculator, and we can clearly see some points, and they even gave us a picture of the table in case we weren't sure what those points were. So, if I know the vertex, I'm going to be in good shape to start the question. Remember, a parabola, general form is not very exciting, but vertex form looks like, whoops, excuse my pen, looks like this. So if I know my vertex, that means I know the h and the k, and then if I have some other mystery point, I know an x and a y, I can substitute in all those values and do some math to find a, and then I'm almost done once I find a. So the vertex looks like it's at the point -1, 4. I can tell that by just kind of estimating off of here, but I also confirm that on my calculator. So what that means is my h is a -1 and my k is a 4. Now I don't care which one of these ordered pairs you decide to use. I like this guy right here. So I'm going to use the ordered pair 1, 2, which means x is 1 and y is 2. And I'm going to substitute in all these values into this blue equation. So y equals, I don't know a, and then x minus the h. Well, minus a -1 means I'm going to add 1 squared, and then plus the k value. Now I gotta solve, so I'm going to subtract 4 from both sides. -2 equals a, 1 plus 1 is 2, 2 squared is 4. So, oh, that was a little weird way to write that. We're going to divide both sides by 4 now. And I find out that my a value for this parabola is a -1/2. Now that I look at the picture, that doesn't really shock me. He's a negative value, means that he goes upside down. And the 1/2 makes him vertically stretch by a factor of 1/2, which really just makes him a little fatter than normal. So, my final answer. I'm going to go back to this blue form. I'm going to keep y and x as variables, but this time I'm going to use the a value I just found. And then I am still going to use the h and k. So x plus 1 squared plus 4. And that is the answer they're going to want to see. Well, oh, 2 problems here. So the vertex here looks to be at the point 1, -4. So that's my h and that's my k. I don't care which point you want to use after that. I like 3 and 4. I like to use positive numbers when possible. So that's the x and that's the y I'm going to be using. So y equals, I do not know a, x minus the h squared plus, oops, plus a -4 could probably be written as a -4. Okay, solving for a, I'm going to add the 4 to both sides. So 8 equals 3 minus 1 is 2. 2 squared is 4. So another 4a, divide by 4 on both sides. I find out that a is 2. Take all these clues that you need, the h, the k, the a, and substitute into our vertex form. 2 x minus 1 squared minus 4. We are done. Okay, 16. Vertex, there's my h, there's my k, and then the x-intercept is at the point 6. What that means is we have an ordered pair of 6, 0. So I think I'm in business. There's my x and there's my y. So y equals, I don't know a, x minus h squared plus the k value. I'm going to subtract 8 from both sides. 6 minus 4 is 2, 2 squared is 4. Get a lot of 4a's. And then turns out that the a value for this problem was a -2. And if I kind of plotted the information they gave me, this would make a lot of sense. That the a is negative because it does open down and he's a little skinny. So -2, my vertex is at 4, 8. Alright, moving on. They want us to graph. Now, I know you guys have beautiful $100 calculators that can do all this work for you, but the less you have to depend on your calculator, the more easily the math later on will come to you. So try to think about how you could come up with these answers without the technology. This is vertex form, which means I could easily tell you what the vertex is. It's at the point -3, -1. Now your calculator would just simply give you a t-table. Well, there's nothing saying you can't get your own t-table. If he's the vertex, that means he's the center point of my parabola, and if I strategically choose symmetrical points, what I mean by that is something to the left and something to the right, a -3. So I'm going to choose a -4 and a -2, because I can choose whatever I want, but symmetry is key to a parabola. Evaluating a -4 up here, -4 plus 3 is -1, Negative 1 squared is positive 1. 2 times 1 is 2. 2 minus 1 is 1. Now watch what cool thing happens here. Negative 2 plus 3 is 1. 1 squared is 1. 2 times 1 is 2. 2 minus 1 is another 1. You're going to notice that if you have done this correctly, your symmetrical y value should come out the same. And let's plot our points. So negative 4, 1. Negative 3, negative 1. And negative 2, 1. And sure enough, I've got a, oops, pretend, a fairly skinny parabola. I mean, it's not super skinny, but it's got a vertex at negative 3, 1. It's opening up because the a value is positive. I think we're good to go. Now, unfortunately, in the next two problems, we are not in vertex form. So we would have to identify where the vertex is. And that's not too bad because we're going to use the axis of symmetry formula. When you are in standard form, the axis of symmetry is the formula x equals negative b over 2a. So for us, the axis of symmetry would be negative 6, so positive 6, over 2 times a, which is 2 times negative 1. Well, 6 over negative 2, better known as negative 3. So what I just found is the x value of my vertex. And you might ask, well, how do I find the y value? Well, how do you ever find the y value? You go plug it in. So be careful here. We're going to square the negative 3 before we multiply by the negative 1. So that's 9 times negative 1 is negative 9. This will become a plus 18. So that's positive 9. 9 minus 4 is 5. And then again, I want to pick symmetrical points. So I'm going to go with negative 4 and negative 2 again. Let's see, negative 4. 16, negative 16, plus 24, 8 minus 4 is 4, and then 4, negative 4 plus 12 is 8, 8 minus, no, I did something wrong, sorry, 4, negative 4, negative 4 plus 12, negative 8, positive 8, excuse me. Positive 8 minus 4 is 4. Oh, goodness. Maybe I should be using a calculator. All right, let's plot these points. And the reason I got a little nervous at first was I thought I didn't have symmetrical points. And when I don't get symmetrical points, that means either I got the wrong vertex or I have the wrong, I just did the math wrong when I found the other points. So notice here I have an upside down parabola. It doesn't surprise me. And that looks appropriate. Now, if you just hate doing that method, you could use completing the square to rewrite standard form into vertex form. Now, personally, I think that's more work than I need to do on this problem, but it is up to you. So this question, standard form again, so unless you want to write it in vertex form, you're going to have to take opposite of b, which is 24, over 2 times a, so 24 over 4 is a 6. So for my t-table, I know the vertex is at 6, and then plug it back in to find the y value. So, boy, I'm definitely using a calculator now. 2 times 36 minus 24 times 6 plus 80 gives me an 8. Some days you just need a calculator. All right, symmetrical points. Something to the left would be 5, something to the right would be a 7. Again, I'm going to use a calculator. 2 times 25 minus 24 times 5 plus 80. I get a 10. And then 2 times 49 minus 24 times 7 plus 80. Please be a 10, and it is. So since I got the same symmetrical y values, I know I did this right. So 5, 10, 6, 8. Sorry if I plot these wrong. Oi. Okay, 7, 10. Oh goodness, and that should be a fairly skinny, oops, parabola opening up. Life is good. Okay, then, I know you guys last year in 2013 Algebra 2 did not do a lot of circle work, but my current Algebra 2 students do a ton of this. So next year when I teach college algebra, hopefully I won't have to do so much of this practice in college algebra. Completing the square. A circle is in the form x minus h quantity squared plus y minus k quantity squared equals r squared. And the reason we like this form is because when it's in this form, I could see where the center of the circle is. It's at hk, and the radius, the length of the radius, is equal to r. So I notice I've got some x terms, and then I also notice I've got some y terms, and I've got some constants. So first thing I want to do is group the x's together, leave blanks, group the y's together, leave blanks, make sure constants are all on the right hand side. So starting with x's, I've got x squared minus 6x. I'm going to leave a blank because I'm going to complete his square in a minute. And then plus y squared minus 4y plus blank equals, and then the 36 is still there, but remember I got to keep things balanced in my equation. So whatever that blue blank was, I got to add him, and whatever that green blank was, I got to add him as well to the opposite side. So the blank is just as before with the quadratics, half of the b squared. So negative 3 squared is 9. Make sure you add it to both the left and right side of the equation. Half of negative 4 is negative 2. Negative 2 squared is 4. Add it to both the left and the right. And now we're going to strategically group. So that and this are all grouped together. X squared minus 6x plus 9 is going to factor into x minus 3 squared. This factors into y minus 2 squared. And then, let's see, I should be able to add this, 49. So my center, notice the negatives are in the formula, so it's opposites. My center is at 3, 2. And my radius, this is the square of the radius, so if I square rooted him, I would see that the radius is size 7. We're going to be doing a lot more work with that circle business, so you're going to get a lot of practice with it. Do not worry.